Okay, let's start from question 4. Each sack of apples at the farmer's market has the same number of apples. 7 apples are needed to make one of Mama's excellent apple pies. I use 3 sacks plus 2 extra apples to make 5 excellent apple pies. How many apples are in each sack? Okay, so when you read these problems, pay special attention to where the numbers are located. Okay, so here we have 7 apples, one of Mama's excellent apple pies, 3 sacks plus 2 extra to make 5 excellent apple pies. So we have these numbers, right? Pay special attention where the numbers are located. And the question is asking that how many apples are in each sack. So this is your unknown quantity, right? So we can use a letter X denote the number of apples in each sack. So although it's a very simple question, I suggest write this sentence in your solution, especially when you are taking an exam, okay? Because your grader will probably look for this specific sentence. Otherwise, they do not know what is your X or what is your Y, what is your R, something like that, right? So my suggestion is to write this sentence in front of all the solutions to make the X clear, okay? So in this way, the readers really know what X here is, okay? So here we use X to denote the number of apples in each sack. And according to the information given that if I use 3X plus 2 apples, I can make 5 apple pies, right? 5 apple pies. And for each apple pie, there are 7 apples, right? So we have this equation, right? Okay, and from this equation, of course, we can solve X. So this gives us 3X equals 33. That means X is 11, right? So actually, to make the whole solution complete, there should be a solution. There should be a conclusion, right? So there are 11 apples in each sack. So this is your complete solution, right? Sometimes you don't have to write the conclusion, but my suggestion is to write everything in this solution. Okay, you can ignore this, but I strongly suggest you to keep the first sentence in your solution. Otherwise, nobody knows what is your X here. Okay? Any questions? No? Okay, let's see question 5. L gets the disease, L-Gibritis, and must take 1 green pill and 1 pink pill each day for 2 weeks. Green pill costs 1 more than a pink pill, and L's pills cost a total of 546 for the 2 weeks. How much does 1 green pill cost? Okay, again, pay attention to all the numbers here. Okay, 1 green pill, 1 pink pill each day. 2 weeks. Green pill cost $1 more than a pink pill and cost a total of 546. Okay, pay attention to all the numbers. And it asks you to find the cost of a green pill. So you don't know the cost of the green pill, right? So we can use a letter X denote the cost of the green pill. Okay, the unit of your X is dollars, right? Okay, so it tells you that a green pill is $1 more than a pink pill. So the pink pill cost X minus 1, right? So a pink pill plus a green pill costs you X1, X minus 1 plus X. Okay, for 2 weeks, that means 14 days. So for 14 days, this will cost you X minus 1 plus X times 14 days. This is your total cost, right? And you also know that the total cost is 546, right? So this is our equation. And from this equation, of course, we can solve X. Okay, so this gives you 2X minus 1 times 14 equals 546. Okay, and then let's check if 546 can be divided by 14. Okay, you can use 3 here, right? $42, 1, 2, 6. And you have how many? 9, right? Okay, so that means 546 is divisible by 14. So this means 2x minus 1 is 39, right? This means 2x is 40. So x is 20, correct? Okay, because x denotes the cost of the green pill. So we can make the conclusion that the green pill costs $20 each. Okay, this is a complete solution for this problem. Again, I strongly recommend to keep the first sentence and the conclusions here, especially in your test or assignment. Otherwise, you might get deducted points in your exam, okay? Any questions? No? Okay, let's see question 6. 3 times a number is 7 more than double the number. What's the number? Okay, this is a simple expression. You have 3 here, 7 here, and double. These are all the numbers, right? Pay attention to these numbers. And you don't know the number and you want to know the number. So we can use a letter X denote the number. Should be this number, right? Let X denote this number. Then according to the information given, 3 times a number, that means 3x, right? Is 7 more than, that means minus something is 7, right? 7 more than double the number. Double the number means 2x, right? Okay, so here you have an equation 3x minus 2x equals 7. Of course, your x here is 7. So the conclusion is this number is 7. right? This is a complete solution to this question. Any questions? No? All right, let's see question 7. My brother is 3 times as old as I am. 5 years from now on, he will be twice as old as I am. How old am I now? Okay, so here you want to find the current age of you, right? So first of all, if you don't know the quantity here, we can use letter X denote my current age. Okay, and then this means my brother's age now is 3x, right? Because here it says my brother is 3 times as old as I am. Then my brother is 3x years old now, right? And 5 years later, okay, 5 years later, I am x plus 5, right? And my brother, sorry, this should be I will be, right? I will be x plus 5, and my brother will be 3x plus 5, right? And it says 5 years later, he will be twice as old as I am. That means his age is twice of my age at that time, right? Okay, so this is our equation. And from this equation, we can find our x. Okay, this means 3x minus 2x is 2 by 5 is 10. And put 5 to the right hand side. Then you have x equals 5, right? Okay, x is 5. What is x? X is my current age. So that means my current age is 5. So our conclusion is I am 5 years old now. Right? This is the whole solution for this question. Any questions here? So basically, to solve a word problem is like to write a little essay. Okay, so make sure you write each part complete. Okay, otherwise, if you use any letters, but you don't give the meaning of the letters, the readers will be very difficult to find, to understand what you are saying here. Your statements might seem clear to you, but not necessarily very clear to your readers, okay? So just try to be thoughtful for your readers, okay? Try to make each of your statements clear here. Okay, let's have a look at question 8. The denominator of a fraction is 7 less than 3 times the numerator. If the fraction is equivalent to 2 over 5, what is the numerator of the fraction? So here you want to find the numerator of the fraction, right? and you don't know this quantity. So we can use letter X denote the numerator of this fraction. Okay, in that case, from the information given that we know the denominator of the fraction is 7 less than 3 times. Okay, 3 times means 3x, right? And 7 less means 3x minus 7. This is our denominator, right? Okay, this is your denominator. That means 3x minus 7. And your numerator is just x. And you also know that this fraction is equivalent to 2 over 5. That means it equals to 2 over 5, right? And here, this is our equation. And from this equation, we can, of course, solve x. Okay. And according to the cross multiplication method, we have 6. Okay. All right, one more step here for you. 2 times 3x minus 7 equals 5x, right? This is from the cross multiplication method. And then expand the left-hand side, gives you 6x minus 14, which is 5x, correct? And move 5x to the left-hand side of the equation. This gives you an x. And move minus 14 to the right-hand side of the equation gives you 14, right? So here we find the numerator of the equation, which is 14. Okay, so let's make a conclusion here. The numerator of the fraction is 14. Okay, this is a complete process of solving this problem. Any questions? No? All right, let's see question 9. I'm thinking of a number. My number is 5 more than 1/2 of my number. What is my number? Okay, here's unknown quantity is your number, right? So let's use an x denote this number. And then according to the information given, my number is 5 more than. That means x is your number is 5 more than, means minus something is 5, right? More than what? 1/2 of my number, 1/2 of my number. Okay, so this is our equation, right? So this means 1/2 of x equals 5, and this gives you x is 10, correct? So x is 10 means this number is 10. Okay, so let's make the conclusion here. Therefore, this number is 10, right? So if you have a doubt, then you can plug your result to the original question to check if your answer is correct. Okay, let's do this. Okay, let's verify if this is a correct answer. Okay, if your number is 10, 1/2 of my number is 5, right? This is 1/2 of this number. And my number is 5 more than. 5 more than means 5 plus 5 is 10. is exactly your number, right? So we have verified this result. This is a true result. Okay? Any questions? No? All right. Let's see the next one. Okay. Question 10. A bag containing some wedges weighs 81 kilograms. When two of the wedges are removed, the weight of a bag of wedges drops to 73 kilograms. The bag weighs 1 kilogram when empty. How many wedges are left in the bag? So here we can draw a diagram to show this question. So initially you have 81 kilograms, and after you remove two of the wedges, okay, two of the wedges are removed, and the new bag is 73 kilogram, right? That means two of the wedges plus 73 kilograms is 81 kilograms, right? So this gives you two wedges is 81 minus 73, which is 8 kilograms, right? And this means one wedge weighs 4 kilograms, right? This is your known information. And it asks you to find how many wedges are left in the bag. Okay, we don't know this number, right? So let's use a letter X denote the number of wedges left in the bag. Okay. We can solve this by using all the known information. What information haven't we used yet? The bag weighs 1 kilogram, right? So here, the weight of the bag plus the number of the wedges left in the bag times the weight of each wedge should be your current weight of the whole bag, right? Should be 73, correct? So this is our equations here. And then from this linear equation, we can find our x. So this means 4x equals to 73 minus 1, which is 72, right? And x is 72 over a 4 gives you 18. So the conclusion is there are 18 wedges left in the bag. Okay, any questions? So, okay, let's see question 11. 4 plus the reciprocal of a number equals 8 divided by that number. What is the number? Okay, again, here you don't know the number, and it's better to use letter X denote this number. And let's have a look what we have known here. Okay, we know that 4 plus the reciprocal of the number. That means x, 1 over x, right? Okay, 4 plus 1 over x equals 8 divided by that number. 8 divided by that number means 8 over x, right? So here, this is our equation. And from this equation, we can find our x. All we need to do is to put all the x's onto the right side of the equation. So this gives you 4 equals 8 over x minus 1 over x. 8 over x minus 1 over x, because we have the common denominator, right? So we can combine them to 7 over x. And next, you know that 4 equals 7 over x. According to cross multiplication, this gives you x equals 7 over 4, right? So here, x is our number, and it equals to 7 over 4. That means the number you're looking for is 7 over 4. Okay, let's make a conclusion. The number is 7 over 4. All right, any questions? No? Okay, let's see question 12. Question 12. 5 years ago, my grandfather was 5 times as old as I was. 3 years from now, my grandfather will be 3 times as old as I will be. How old am I now? Okay, here you want to find how old am I now. Don't know this number, so let's use a letter X denote my current age. Okay, so 5 years ago from now on, 5 years ago from now, I know that I was X minus 5 years old, right? This is my age 5 years ago. And 5 years ago, my grandfather was, it says, was 5 times as old as I was, right? So 5 years ago, my grandfather was 5 times X minus 5 years old, right? This is my grandfather's age 5 years ago. And you also know that 3 years later, I will be X plus 3 years old, right? This is my age in 3 years. And my grandfather will be how old? He says 3 years from now, my grandfather will be 3 times as old as I will be. Okay, that means 3 times x plus 3, right? This is my grandfather's age in 3 years, correct? And the difference is 8 years, right? So 8 years is 3 times x plus 3 minus 5x minus 5, right? Because this is my father's age in 3 years. This is my father's age 5 years ago. There is an 8-year difference between these two numbers, right? So if you use your father's age in 3 years, your grandfather's age in 3 years, minus your grandfather's age 5 years ago, the difference is 8. So this is our equation. And then from this equation, we can find that 8 equals, okay, let's expand everything on the right-hand side of the equation. This is 3x plus 9 minus 5x plus 25, right? And you want to solve for x, then let's move x to the left-hand side of the equation and all the constants to the right-hand side of the equation. And this gives you 2x equals 9 plus 25 minus 8. This is actually 26, right? So x here is 13. So what is the meaning of x? X denotes my current age. So that means my current age is 13. So let's make a conclusion. Therefore, I am 13 years old now. Okay, any questions? No? Okay, let's see question 13. Okay, question 13 and question 14 are actually typical matching problems. Okay, we call these matching problems. Okay, let's see question 13 first. We want to build a set of shelves. The width of the set of shelves needs to be 4 times the height of the set of shelves, and the set of shelves must have 3 shelves in it. If there are 72 feet of wood to use to build a set of shelves, what should be the dimensions of the set of shelves to be? Okay, to solve the typical matching problems, it's better for us to draw a diagram. Okay, here you want to build a shelf, right? Okay, suppose it's a rectangle shelf and it says must have 3 shelves in it. That means this is our first shelf, right? Where you can put your books. This is your second shelf, and here this is your third shelf. It has 3 shelves in it. And also you know that the width of the set of the shelves needs to be 4 times the height of the set of the shelf. So here you want to find the dimension. So let's use a letter X denote the, how about the height? It does not matter if it's the height or the width. All right, because the height is smaller, so usually we use a letter to denote the smaller quantity. That makes your equations look more concise because you can avoid using ratios, right? So let x denote the height of the set of shelves. Okay, of course, you should list the unit of x, okay? Because sometimes you find that not all the quantities have the same unit. So it's better to list the unit here and make sure all the quantities are in the same unit. Of course, here the unit is feet. Okay, so here we have our height, which is x. And we also know that the width of the set is 4 times the height. Okay, so that means here the length is 4x, right? So in order to make the shelf, we have 1, 2, 3, 4. 4x, right? And here we have 1x here and 1x on the other side. That means plus 2x. And how much materials do we have? We have in total 72 feet of wood, right? So 72 feet. That means 4 times 4x plus 2x equals 72, correct? Do you understand this step? This is our equation to find x. Okay, so next, let's expand all x's, which will have 16x plus 2x equals 72, right? And this gives us 18x equals 72. That means x is 4. Okay, x is the height, so that means we can make a conclusion that, okay, I'll briefly write the conclusions here, okay? So that means the height is 4 feet. So how about the width? That means the width is 4x, right? 4x is 16, so the width is 16 feet. This is our dimension, okay? Because it asks for the dimensions, that means you should give both the height and width, okay? Any questions? No? All right, let's see question 14. Okay, again, question 14 is also a typical matching problem. Here we want to fence in a field whose length is twice the width and we have 80 feet of fencing material. Okay, so here you have a fence. And also it asks you to find the dimensions of the field. So let's use letter X denote, okay, which is smaller. It says the length is twice the width. So let X denote the width. Okay, so the unit is also feet. Okay, so here the width is X, right? And we also know the length is twice the width. So the length here is X. Okay, so assume this is a rectangle fence. That means you have another X here, another 2X here, right? So that means if you add all the edges, the length of all the edges, which is 2x plus x plus 2x plus x, this should equal to the total length of your fencing material, right? Which is 80. Okay, so this is our equation. And the left-hand side gives you 6x. Right-hand side is 80. So that means our x is 80 over 6, which can be simplified to 40 over 3, right? And of course, here 2x is 80 over 3. Okay, so that means the width is 40 over 3 feet, and the length is 80 over 3 feet. Correct? Okay, any questions? No? Okay. Let's see question 15. Okay, question 15 is a typical pricing problem. Okay, it tells you that a shirt is on sale for $15 and has been marked down 35%. And it asks you how much was the shirt being sold? Being sold for before the sale. So here we want to find the original price, right? So if we don't know the quantity here, we can use a letter to denote the quantity. Let X denote the price of the shirt before sale. Before the sale. Okay, of course, here the unit is dollars, right? So what we have known here, we know that it has been marked down 35%, right? That means the original price down by 35% of the original price. This is the current price, right? The current price is $15 because it says here it's on sale for $15, right? So this is our equation here. This means x minus 0.35x is 15. So here we have 0.65x is 15. So x is 15 over 0.65, which is, we need to simplify this, right? 1500 over 65, okay, which is 300 over 13. So because it's a practical problem, it's an application problem, so it's better for us to denote this number using a fraction, using a decimal. Because in our real life, if it's a price, usually it will be something 0.2 decimals, right? So it's better to write it in this way. Of course, it's approximately 23.08. So here the conclusion is, you can say that the original price is $23.08. Correct? So this is a pricing problems. Okay, any questions? We're good, right? Okay, let's see question 16. So question 16 and question 17 are both typical traveling problems. So in traveling problems, we shall use a formula like this. The distance equals to the speed times the time taken. Okay, do you understand this equation? Have you learned this in your physics class? Okay, so if we are clear with this, distance is speed time times the time taken. For example, if you travel at 10 miles per hour and travel at that speed for 1 hour, that gives you 10 miles, right? This is your distance. So this is a basic formulas we shall know to solve some traveling problems. Okay, so here we can draw a diagram to illustrate this question. Two cars are 5 miles apart, 5 miles apart, and moving directly towards each other. So you have a okay, so you have a car here. Let's say it's a car A traveling at some speed, and car B traveling towards A, right? And the total distance here between these two cars is 5 miles. And one car is moving at a speed of 1 miles per hour. Okay, for example, we say that car A traveling at 100 mph. Mph means miles per hour, okay? And car B travels at 70 mph. Assuming that the cars start moving at the same time, how long does it take for the two cars to meet? Okay, it asks you to find the time taken for the two cars to meet. Okay, let's use letter T because it asks for a time, right? So this time, let's use a different letter. Let T denote the time taken for the two cars to meet. Okay, and unit, don't forget the unit. The unit is hours. Then what we have already known here. We know distance is speed by time, right? So by the time they meet here, what's the distance traveled by A? The distance traveled by A is A's speed, which is 100 mph times T, right? And also, what's the distance traveled by B? It should be B's speed, which is 70 mph, times time taken, which is T, right? And we also know that the distance traveled by A plus the distance traveled by B is 500 miles, right? Because initially they are 500 miles apart. So that means 100t plus 70t equals 500 miles, correct? Okay, and then according to this formula, 170t equals 500. And this actually gives you t is 500 over 170, which is 50 over 7, which is approximately 2.94 hours, right? So our conclusion here, it will take 2.94 hours for them to meet. Okay, any questions? No? Okay, let's see next one. Question 17. Actually, the methods are the same, right? Says two planes start out 2,800 kilometers apart and move towards each other. Okay, so you have a plane here, move on one direction, and another plane here, move on the opposite direction. And they are 2,800 kilometers apart, right? This is our initial settings. One plane's speed is 75 km per hour. And this time it asks you to find the speed of the, oh, sorry, this is not the speed of the plane. You know that the difference between the speed of the two planes is 75 kilometers per hour, right? And this time it asks you to find the speed of each plane. So there are two quantities that we don't know, right? So let me use a letter V. Let V denote the speed of one plane. It's workable, right? The unit is kilometers per hour. And how about the speed of the other plane? Then the speed of the other plane is how many? Could be v plus or v minus, right? So suppose the v here is a slower plane, and then the faster plane travels at v plus 75 kilometers per hour, right? Okay, so here one plane travels at v plus 75 and another plane travels at v. So according to distance is speed by time, we know that by the time they meet here, plane A has traveled plane A traveled v plus 75 times t, right? And here it tells you that after 3.5 hours they meet. So that means times 3.5 hours. Okay, plus the distance traveled by B, which is V times 3.5 hours, right? And this distance is the initial distance that they are apart, which is 2,800, right? So here, this is your equation. Okay, so this gives you actually 7v plus 262.5 equals 2800, right? So here we can solve v is actually how many? Okay, let's use a calculator now. I don't want to calculate by hand. Minus 7. Okay, this number is 362.5. The unit is kilometers per hour, right? So this is the speed of the slower plane. And v plus 75 is the speed of the faster plane, right? This is 437.5 kilometers per hour. Okay, so the conclusion is slower plane travels at 362.5 kilometers per hour, and the faster plane travels at 437.5 kilometers per hour. Okay, any questions? No? Okay, let's see question 18 and 19. Question 18 and 19 are typical work rate problems. Okay, we call this work rate problems. Okay, let's have a look at question 18 first. A pump can empty a pool in 7 hours, and a different pump can empty the same pool in 12 hours. How long does it take for both pumps working together to empty the pool? Okay, in working rate problems, the basic formula we're going to use is this. The portion of job done in a given time equals the work rate times the time spent working. Okay, have a look at this formula. Do you understand this? The portion of the job done in a given time is the work rate times the time spent working. It's some kind of like the distance equals speed times the time. It's pretty similar to the previous formula. Okay, any questions about this? Portion of job done in a given time equals work rate times time spent working. Okay, so now you know that pump A can empty a pool in 7 hours. So that means the pump A's work rate is 1 pool over 7 hours, right? That means for each hour, it can empty 1 over 7 pool, right? This is work rate of pump A. So how about pump B? Pump B's work rate is 1 pool. It can empty 1 pool in 12 hours, right? 1 pool over 12 hours means in each hour, it can empty 1/12 of the pool. Okay, understand? We have a problem here. Okay, so if we use both of the pumps, the combined work rate is how much? One pump can empty the pool 1/7 pool per hour. Another one is 1/12 pool per hour. So if we combine them together, you will get 1 over 7 plus 1 over 12, which is actually 19 over 84. pool per hour, right? This is a combined work rate. Do you understand? So the problem here is you want to empty one pool, right? And the work rate is 19 over 84 pool per hour. So can you tell me how many hours will it take to empty the whole pool? You should use one pool over your work rate, right? Which is 19 over 84. So this gives you 84 over 19 hours, which is approximately 4.42 hours to complete the whole task. Okay, and I'm not gonna write the conclusions here. You should complete the conclusions by yourself. Okay, and make a conclusion here. Okay, any questions? Any questions? No? Okay, let's see question 19. Okay, again, question 19 is a typical work rate problem. So here, the question is very similar to question 19, except this time it asks you to find one of the person's work rate, right? So let's we use, oh, sorry, it asks you to find the time that it will take one of the persons to complete the job. So this time we use a letter T to denote the time taken for John to complete a task by himself. That means his own work time, right? The unit is hour. So this time we know that Mary's work rate is 1 office over 5 hours, right? Because you know that Mary herself can clean one office in 5 hours. That means her work rate is 1/5 office per hour. Okay, this means for 1 hour, she can clean 1/5 of the office. And John's work rate is, because we have used the letter T to denote the time taken for John to complete the task by himself, right? So John's work rate here is 1 office over T hours, right? So John's work rate is 1 over T office per hour, right? That means for 1 hour, John can clean 1 over T's office. Understand? So the combined work rate is 1 over 5 plus 1 over T, right? If they work together, the combined work rate is 1 over 5 plus 1 over T office per hour, right? And we also know that by working together, they can clean the office in 3.5 hours. Okay, that means the combined work rate times the time taken they can complete the whole task. The whole task is actually one office, right? Equals 1. Do you understand this? Okay, so this is our formula here. How do we solve it? Okay, first, let's expand this formula. This gives you 0.7 plus 3.5t, which is 1, right? And move the 0.7 to the right-hand side of the equation. This gives you 3.5t equals 0.3. And t is 3.5 over 0.3, which is 35 over 3. Okay, because it's a time, so it's better to use a decimal format, which is approximately 11.67 hours, right? So the conclusion is it will take 11.67 hours for John to complete the task by himself. Okay, so that indicates the efficiency of John is not as good as Mary, right? Okay, any questions? Okay, again, if you have done question 18 or question 19 incorrectly, you should update your error book, okay? Because they are very typical. They are the very typical problems involving work rate. You will see this a lot in non-variable linear equations applications. Okay, have a look at these questions. If you don't have any questions, then you can leave the class, okay? And please remember to download the new assignment later today or early tomorrow. And also, I will upload the teacher's notes to our Google Classroom. Okay, I'll do it now. Okay, the teacher's notes are up onto the Google Classroom. You can download it if you need that. If you have no questions, you can leave the classroom. Have a nice weekend.